today is focused on carbon reduction, right? And I'll talk about three main topics. So alternative fuels, calcined clay, and carbon neutrality. So let's start with the alternative fuels. And gasification is the process behind most of the technologies that I'll be presenting today, right? So going directly to Dynamis portfolio, we have two types of gasifiers. The first one is the suspension type gasifier that we name D-gasifier. The second type is a fluidized bed gasifier that we name the DF bed gasifier. Today I will focus mainly in the fluidized bed gasifier. So, as not everyone is familiar to this equipment, let's start describing it. So, this equipment is the fluidized bed, and it uses a bed of sand to gasify solid fuels. The solid fuel here is conveyed from the storage to the dosing system by this belt conveyor and introduced to the gasifier by a dosing system installed, located in this building here, right? So internally, the gasification process takes place in this equipment, and the generated syngas is connected to the process by a duct. Internally, the D-gasifier is a chamber. The DF bed gasifier is a chamber lined with refractories and filled with sand up to this level, with hundreds of nozzles to inject air and generate bubbling, like you see here. Hot sand and the intense heat exchange makes that the fuel start reacting almost immediately. So hot sand also acts as a thermal inertia that allows for fluctuations in the moisture, the fuel moisture, and the fuel particle size. If I would choose a single word to define the fluidized bed gasifier, it would be stability. So I can list several advantages of this equipment. So first, it avoids major modifications to calciners to increase residence time. Second, it's easy to install. So since it's installed on ground level, it does not require major civil works to modify the preheater. So we reduce drastically downtimes for erection. It is capable to handle fuel particles up to 150 millimeters and moisture content up to 30%. We can use the same technology for both process, calciner and main burner. So theoretically, we can achieve 100% thermal substitution rate in the pyro process. With a suitable design, it's possible to retain the ashes inside the equipment. So this is the reason why we say that this equipment is a perfect match for white clinker cement. So we can use alternative fuels, but the ash, since the ash does not go to the process, there is the white color of the clinker is not affected. In a project that we are conducting now in Slovakia, we are increasing the thermal substitution rate from currently 7% to 70%. And finally, another important feature of this equipment is related to the gas cleaning. Since the gasifier is separate from the process, right? We can add sorbents like limestone to the bed and remove the acids like chlorine, like sulfur, like fluorine. We can clean the syngas. So these impurities like chlorine are removed from the syngas, and then we can achieve very high thermal substitution rates without the need for a bypass system, right? So two important points of this chlorine removal. So first, we use limestone as sorbent. And second, we can reach more than 90% abatement using a calcium to chlorine molar ratio of 3:1. And how can we remove this, the chlorine from the system? So what we know that is that the chlorine reduces the melting point of the sand. So we notice that the bed starts to clamp, the bed starts to form lumps, and then when the chlorine content increase. So to separate the chlorine is just a matter of separate the lumps from the final sand, from the final particles. So using a screen, we can circulate the ash, the sand, and the coarse material we reach in chlorine, we discard, and the fine material we recirculate to the bed, right? Okay. So, reference. This is a plant in operation in Brazil, 100% biomass. So it's not a concept, it's not an idea, this is real in operation, and you are invited to visit this plant. So operating 100% biomass and connected to a grinding mill. So this is the equipment, and this is the biomass. So this size of this book is 200 millimeters, more or less. So in average, you can see that the biomass is more than 100 millimeters in size, right? So another project, another reference, now it's a project that I mentioned, this project in CRH, Slovakia. We are supplying a gasifier for a white clinker cement to achieve 70% TSR, thermal substitution rate. And the idea is to gasify, to use the gasifier here, conduct the syngas, generate syngas, this duct conveying the syngas to the main burner and inject into the kiln, right? So this is how we are proposing to achieve this very high TSR even in white clinker cement. Remember, with this is only possible because the ash remains in the equipment, right? So before I move to the next topic, I'd like just to highlight that we have the technology to achieve 100% thermal substitution rate using alternative fuels or biomass. So now, going to calcined clay. And at Dynamis, calcined clay has several meanings. Calcined clay means dozens of reference in Dynamis. Starting from the very first reference, our kiln installed at C-Plan, now part of VK Group. We commissioned this kiln in 2009, more than 16 years ago, to produce 550 tons per day. Now we are achieving more than 700 tons per day. And at that time, the technology that we knew was rotary kiln, rotary cooler, and the very first degasifier. The degasifier is the innovative equipment here for this plant. Another very important reference of us, already mentioned several times this morning, is our project in Colombia, Cementos Argos in Colombia, the world's largest calcined clay line. It is a hybrid technology where we combine, again, innovation, right? We combine flash technology with rotary technology. We commissioned this kiln in 2019, and the main point in this project was the very high iron content. This was the first time we used the color control technology in a calcined clay line. Then another very important reference for us, still in a project, it's Sozella's, in Simpor Group, Sozella's plant. So we are modifying kiln number 2, this in the middle, to converting from clinker production to calcined clay production. And here, several challenging points. For me, I would like to list 2 of them. This will be the first time we will use a clinker-grade cooler to handle calcined clay. So this will use the existing clinker cooler, grade cooler. We will modify it to handle fine material, fine calcined clay. And the other very important topic is that we will achieve 80% thermal substitution rate. And to achieve that, we will have this rocket mill from ATEC. So at Dynamis, as I mentioned, C-clay has several meanings. At Dynamis, C-clay also means dozens of technical developments. And the first one is this one, the degasifier. Very important to achieve, in the very first moment, achieve the quality that we needed for the calcined clay. But then, now, it's very important to achieve 80% TSR, 9% TSR, and also for the color control. So, color control, this is what we are doing in Colombia. We are starting from this and producing this. Now, since 2019. And more recently, this development, there is a partnership between Dynamis and IKN to modify clinker grade coolers to handle fine material like calcined clay. We, Dynamis, we are responsible for developing the solution, the process solution, and IKN is more in the mechanical development. And now, we are proposing this, that is to modify the preheaters of existing clinker kilns to be as a dry scrubber. The idea is to split, to divide the preheater in two parts, the bottom part to collect the dust and recirculate this dust that's normally it's a very good clay, and the top part to use, inject hydrated lime and clean the flue gases. So basically, to conclude this part, this topic, I would say that if the client wants to go for a new project, a new line with a rotary kiln or a flash calciner, we will be, based on our 20 years, more than 20 years of experience, we will be very comfortable to present our solution. But if the idea is to start slowly, using existing assets, modifying existing clinker lines, we have the complete package to convert the existing clinker kiln into what we're naming multi-task kiln. One kiln, two products. Clinker during part of the time, calcined clay during other part of the time. So all the solutions that I presented before are already thought to operate with both clinker and calcined clay, right? So now, to conclude, to go into finally to the carbon neutrality, here the idea is to demonstrate that using our gasification technologies that can be a degasifier or a DF bed gasifier in a calcined clay line, in a calcined clay kiln, we can achieve carbon neutrality, producing calcined clay, carbon neutrality. And similarly, in a clinker line, using a DF bed gasifier, one for the calciner, another one to the kiln for the main burner, we can achieve 100% thermal substitution rate. So to conclude my presentation, I would like to highlight that using high amounts of alternative fuels and biomass, combined with the production of SCMs like calcined clay, it is a mandatory pathway for carbon neutrality. Thank you very much.